Hello everyone. Welcome to the world of embedded system. In our previous session, we learned what a microcontroller really is. We also explored the CPU, RAM, and flash memory, and also double EEPROM. We also learned something very important called the memory map. By the end of our session, we understood that everything inside a microcontroller has an address. Flash has an address, RAM has an address, even the peripherals such as GPIO pins, timers, UART, ADC has their own addresses. But today, I want you to think about something. Suppose I connect an LED to a microcontroller and I want to write a program that says turn on the LED. How does that instruction actually reaches the hardware? How does software communicate with the outer world? The CPU can execute instructions. The CPU can read memory, but how does it controls the peripherals? The answer lies in something called as resistors. Today's session is one of the most important session in embedded system because resistors form the bridge between software and hardware. We will understand what is resistor, why resistors are needed, CPU resistor difference between the CPU resistors and peripheral resistors, and also we'll learn about memory mapped resistors, and we'll be seeing how software controls hardware using resistors. So let's get started. Firstly, let's start with the word itself. The word resistor sounds technical, but the concept is actually very simple. A resistor is a small storage location used to store information. Now you might think, wait a minute, didn't we already learn about RAM in the previous video? Yes, we did. RAM is also used to store information. So, why do we need resistors? The answer is speed. Resistors store only a small amount of information, but they are extremely fast to access. That's why the CPU uses resistors whenever it needs to perform operations quickly. You can think of resistors as the CPU's immediate workspace. Whenever calculation happens, even whenever the comparison happens, whenever instructions are executed, resistors are involved. This is why resistors are often called as the fastest memory inside the microcontroller. To get the free resource and today's PPT, please go and join our Telegram group. The link will be given in the description box. Now let's understand something interesting. There are actually different types of resistors. The first category of resistor is CPU resistor. These resistors exist inside the processor itself. Whenever the CPU executes instructions, it continuously uses these resistors. For example, suppose we write a simple program, we create two variables. Okay, we add them together and then we store the result. To us, it looks like a simple one line code, right? But internally, the CPU performs multiple operations. It reads the value, it temporarily stores them, it performs an calculation, it stores the result. All of these happens using the CPU resistors. The CPU does not perform calculations directly from the flash memory. It doesn't perform calculation directly from the ROM. Instead, it loads information into the resistors and then works on it. It makes execution extremely faster. So, whenever someone asks, where does the CPU actually performs calculation? The answer is inside its resistors. Now, let's move beyond the CPU. Suppose you have an LED connected to a microcontroller. Can the CPU directly touch the LED? No. Can the CPU physically switch on the LED? No. There needs to be some mechanism between software and hardware, right? And that mechanism is resistors. Think about a TV remote. When you press the volume button, you're not directly controlling the speaker, you're sending a command. Something inside the TV receives that command and adjusts the volume. Resistors work in the similar way. Software writes information into the resistor. The hardware absorbs the information from the resistors, and based on that value inside the resistor, the hardware will react. So, we can think of resistors as control panels for hardware. Software changes the resistor, hardware responds. That's the fundamental idea. Okay, now let's introduce another category of resistor, which is peripheral resistors. These belong to hardware peripheral. For example, GPIO pins, timers, UART, ADC, PWM, all these are peripherals contains resistors. Let's take GPIO as an example. GPIO stands for General Purpose Input and Output. The GPIO peripheral needs to know, should the pin be an input? Should it be an output? It should be high or it should be low. All of these settings are controlled through resistors. Okay. Similarly, timers has resistors, UART has resistors, even ADC has its own resistors. Every hardware module inside a microcontroller contains resistors. This is how software configures and controls peripherals. For today's PPT and to get the free resources, please go and join our Telegram group. The link will be given in the description box. Now, let's connect today's topic with what we learnt in the previous video. Remember the memory map. We learnt that every resource inside the microcontroller has an address, right? Well, resistors also has an address. This means a resistor isn't floating somewhere inside the chip. It exists at the specific address. For example, flash memory may start at one address, RAM may start at another address, GPIO registers may start at another address, the timers will start at an address, and the CPU access these resistors using their own addresses. This concept is called memory mapped input or output. The idea is very simple. Hardware resistors are placed inside the memory space of microcontrollers. From the CPU's perspective, accessing an resistor looks very similar to accessing an memory. That's what makes microcontrollers so efficient. Let's imagine uh, about an LED connected to a GPIO pin. Okay, suppose the LED peripheral contains a resistor responsible for controlling output. Inside that resistor, one bit controls the LED pin. When software changes that resistor value, the GPIO hardware notices that change. Okay, and then the pin changes its state from on to off or off to on. Notice something important. The software never directly talks to the LED. Instead, the communication path looks like this. Firstly, the CPU, then firstly the software, then the CPU, then the resistors, and that resistor, from that resistor, the information goes to the GPIO hardware, and then from the hardware to the LED. This is how software controls the physical world. And this same concept applies to motors, sensor, displays, communication interfaces, and almost every peripheral inside the microcontroller. Okay, why beginners start these embedded journey using libraries? For example, a function may turn on or off the LED using a single line of code. It looks simple, but behind the scene, those functions are modifying resistors. Libraries make programming more easier, but resistors are what actually controls the hardware. This is why every embedded engineer must understand the resistors. If you can understand the resistors, you can read the data sheets more easily. Okay, so what these data sheets mean in the sense, like, now whatever we are learning about a microcontroller, that information will be present inside the particular microcontroller's data sheet. Okay, so I have mentioned about the addresses also, right? So though in the data sheet specifically, it will be given to you that in this particular address, this particular thing is present. For an example, for in the address of 001, the RAM has been there. RAM address is 001. If you want the flash memory address, it can be 008 or something else also. So this particular information will be provided to you in the data sheet. And if you can understand the resistors, you can easily understand, like you can easily read the data sheet and easily understand it even more better. And you can also debug the hardware problems. You can also understand how peripherals work internally, and most importantly, you can understand what your code is actually doing inside the microcontroller. So we are coming to the end of our session. So today we learned one of the most fundamental concept of embedded system, I can say. So we learned about the resistors and why it is um exist in the microcontroller, and also we learned about the CPU resistors and the peripheral resistors. We learned how the resistors are connecting the memory map, and also we got to know that how software controls the hardware using resistors. Okay, so thank you all for joining me in this video. So